across primary coil. Because of these windings, it will induce a magnetic flux. If we allow AC supply across primary coil, because of turns, because of winding, it will generate a magnetic flux. And that induced magnetic flux will induce coil. We are supplying input voltage. Because of that supply voltage, we will get a magnetic flux. That magnetic flux will induce a voltage in the secondary coil. That is our output. Then what is the importance of this gray color one? This gray color one is called as core, transformer core. If you don't have this core, and if you place primary coil near the secondary coil, we will get very less voltage, less induced voltage in the secondary coil. If you are not using transformer core, and just if you place primary coil near the secondary coil without having direct contact, we will get very less voltage, less induced voltage in the secondary coil. So here we have magnetic transformer core. This transformer core is also a metal. That means it is a conductor. But we have to coat it with the insulating layer. That means even though we have primary coil windings on the transformer core, in between this primary and secondary, we have an insulation cover. That means primary coil and core does not have direct contact. Secondary coil and core does not have direct contact. But what is the use of this transformer core? So I already said that because of the generate a magnetic flux. That magnetic flux will generate a magnetic flux in the transformer core and the secondary coil. With the help of transformer core magnetic flux, that is phi, we will get exact output or expected output from the secondary coil. That is the use of transformer core. Primary voltage is called as Vp, secondary voltage is Vs, number of turns in the primary coil P, number of turns in the secondary coil is S, Ns, and the flux linkage is phi. This is the construction and this is the symbol of the transformer. If you observe here, students, number of turns in the primary coil is equal to number of turns in the secondary coil in this figure and in this figure. If you observe, number of turns are equal in the number of turns in the secondary coil. But most of the cases will not have this type of equal number of windings. Secondary coil should have more number of turns than the primary or less number of turns than the primary. So if you observe here a problem, you can understand the relation between turns. A voltage transformer has 1500 turns of wire on its primary coil and 500 turns of wire for its secondary coil. What will be the turns ratio of the transformer? Here you can see NP by NS and answer is 3:1. That means if you apply 3 volts at the primary coil, you will get only 1 volt. That is step down transformer. In step down transformer, output is less than the input. In step up transformer, output is greater than input. That is the relation between number of turns of secondary coil. And we have discussed the importance of primary coil, secondary coil, and the importance of transformer core, relation between the primary coil number of turns and secondary coil number of turns. If we have more number of turns in the secondary than the primary, you will get more voltage as output. If we have less number of turns in secondary than the primary, you will get less output voltage. Students, I am forwarding this website link in the chat box. For 5 minutes, you can see the theory. Next, we will go to our experiment. Go to this website and read out the details of the transformer. Students, today's our experiment is linear variable differential transformer, LVDT. LVDT means linear variable differential transformer. Its construction will be like this. Its construction will be like this. If you observe primary coil as we have in the regular transformer, but instead of having one secondary coil here, we have two secondary coils. And these two secondary coils are arranged in LVDT in such a method If secondary 1 is producing positive voltage, secondary 2 will produce negative voltage. Here we have two coils. If secondary 1 is producing positive voltage and secondary 2 will produce negative voltage. And core you can observe. In regular transformer we have this type of core. Gray color one is the core. But here we have a rectangular core which lies between primary and secondary. So depending on the application, we can design transformers in different patterns. And here we have designed transformer like this. And students, in regular transformer, core is not movable. Core is fixed. So here we have secondary 1 and secondary 2. We have secondary 1 and secondary 2 coils. If secondary 1 is producing positive voltage, secondary 2 will produce negative voltage. Okay. And I said this core is movable towards left and toward right. If core is covering both primary, secondary 1 and secondary 2, if both coils, if core is covering both secondary 1 and secondary 2, you will get 0 voltage as output, because secondary 1 is producing positive voltage, secondary 2 will produce negative voltage. So result will be S1 minus ES1 minus ES2. ES1 means voltage developed in the secondary 1. ES2 means voltage developed in the secondary 2. So if core is covering both secondary 1 coil and secondary 2 coils, we will get voltage as ES1 and ES2, and resultant output will be 0. This is the equation. Differential output is equal to ES1 minus ES2. LVDT, linear variable differential transformer. So if I move core towards left, it will cover only secondary 1. And if I move core towards complete right, it will cover only ES2. So I will get only negative voltage as output. So in this way, depending on the position of the core, we will get different outputs. And depending on the different outputs, we can estimate the displacement of the core. If we connect any movable object to core, that movable object displacement we can estimate by using the LVDT. So in this way, we have to move rod which is connected to core in the primary coil, and now we will get the secondary coils.
Citation.
We have to apply input voltage to the primary coil.
While two secondary coils having equal number of turns are wrapped around either side of the cylinder at equal distances from the primary coil. The two secondary coils are connected in series, generating an AC output voltage.
We have to connect a voltmeter to the secondary coils. If you observe, two connecting wires are coming to the voltage voltmeter. One is from the secondary one, another one is from the secondary two.
With the core at dead center, no voltage appears at the secondary output. But as soon as the core moves, by even the smallest amount, a differential voltage is induced at the secondary output. The phase of the voltage is determined by the direction of the core's displacement, while the amplitude is determined more or less linearly by the generating an
If you observe, if you move core towards right, you are getting positive voltage.
AC output voltage. With the core at dead center, no voltage
When core lies at exactly middle position, you will get zero output.
appears at the secondary output. But as soon as the core
If you move core towards the secondary two, you are getting positive voltage.
moves by even
So there is a condition to get only always secondary output will be positive or secondary one will be negative. We can interchange them. In some LVDTs, secondary one will give positive voltage, secondary two will give negative voltage. In some other LVDTs, secondary two will give positive voltage, secondary one will give negative voltage. So here in this animated video, so secondary two is producing a positive voltage as output and secondary one will be negative.
in the smallest amount, a differential voltage is induced at the secondary output.
See, if you move core towards secondary one, you are getting negative voltage.
The phase of the voltage is determined by the direction of the core's displacement, while the amplitude is determined more or less linearly by the magnitude of the core's movement from the center. Signal conditioning is required.
Then observe the video once again.
In the middle of the cylinder and is energized by a constant amplitude AC source known as primary excitation, while two secondary coils having equal number of turns are wrapped around either side of the cylinder at equal distances from the primary coil. The two secondary coils are connected in series, generating an AC output voltage. With the core at dead center, no voltage appears at the secondary output. But as soon as the core moves, by even the smallest amount, a differential voltage is induced at the secondary output. The phase of the voltage is determined by the direction of the core's displacement, while the amplitude is determined more or less linearly by the magnitude of the core's movement from the center. Signal conditioning is required to convert the analog AC output to either 5 volts DC, 4 to 20 milliamps, or whichever format is compatible with your data acquisition system. This differential design gives the LVDT significant advantage.
And this is another video to understand the
Rewind.
students. This is our primary coil. This is our secondary one coil. This is secondary two coil, and here we have connected input voltage for the primary.
Now look at former. It is surrounded
This
by
is
one
primary
primary.
coil, and you can see this is our core. Internally, we have connected core.
Winding. Called as primary winding is excited.
Input
And
voltage
two
range is 1
secondary
to 10 volts.
windings
This is
are called as
secondary
secondary
one, and
coil
this is
1
secondary two coil.
and secondary coil 2 and magnetic core,
So
which is 3.
here we have a pointer to move core. So here you can see core, and this is also a core. Now we will move core. We can move in both directions.
Now see how LVDT will T. First condition is condition core at. This in detail. EMF.
Initially,
Induced.
core is at middle position. Internally, you cannot see core in practical LVDT. Because of core is taking at the middle position, we are getting E1 is equal to E2. So total output will be 0.
Is same in both coils, which result EMF. Induced is
You can
same
see
in both coils.
displacement scale. Core is at 0th position.
Thus, from the measurement of the output, the core movement
Displacement is 0 mm.
So a phase-sensitive detector is a useful circuit to make the Lvdt with the primary side. Move in
If
the
you move
left
core
hand side.
towards left, core is producing magnetic flux, and magnetic flux is near to the S1 because we have moved core towards left.
Direction. Then the EMF voltage induced in the secondary coil 1 is greater when compared to the EMF induced in the secondary coil 2. Therefore, the net output will give negative displacement.
So he moved core towards right. Now we'll see output.
3. When an external
Positive
force
voltage.
is applied.
See, if you move core towards left, you got negative voltage, and if he has moved core towards right here, so this is the present position towards right. Output is positive voltage because core is near S2 coil, so magnetic flux is near S2. We have very less magnetic flux near the S1, so we'll get positive voltage as output.
The EMF led to the EMF, the T having many advantages.
Now you can see advantages of Lvdt. We have high range for the displacement, to measure displacement, no frictional losses. So core does not have direct contact with the primary or secondary coils. It is moving in free air. High input and high sensitivity. High input and high sensitivity. Sensitivity means if we move even 1 mm or less than 1 mm, we will get a change in output. That is the high sensitivity. Low hysteresis. If you move middle position to left, and again if you bring that core to the middle position, at each step you will get same output voltage in the first to left and left to initial position. In both ways you will get same output voltages. So Lvdt has low hysteresis. Linear displacement acts as a secondary transducer. So we have primary transducers, secondary transducers, and in our subject we will discuss all those topics in coming classes. And here we have another practical Lvdt students.
Sensor and plot the graph.
In our
between
laboratory,
micrometer
we have this type of Lvdt. In our college, we have this type of Lvdt now. So, experiment procedure you can see now.
displacement and error percentage. So we need to basically find the error. Okay. So first we need to calibrate it. So for calibrating, first we'll put this micrometer
See,
on.
to move the core in previous video he has used hand, but to move core in a smaller displacements we are using screw gauge. So we are pulling core by the help of screw gauge.
Yeah. So yeah, I guess it's around on 10. Once you do this on 10, you have to change this value and bring it to 0. You have to use the knob in the bottom. You can see over here it's written 0, so this is used for getting it to 0. Okay.
When core is at middle position, we should get 0 output.
Right. So I guess that's enough. Then move this micrometer to 20. Okay, once you move this to 20, you have to set it over here to 10. For that you have to use the knob on the top. Its span is written over here. Okay. Okay, I guess it will fluctuating, but yeah, okay. Approximate, get it to 10, okay. And this is a tabular column over here. Okay. Here in the 37, give the percent.
Again, he
you
is
guys remember,
moving
right?
4 in opposite direction.
When we kept it on 10, the reading should be 0.
This is our core rod. Internally, this rod is connected to core. So this is about Lvdt students. Now we'll go to our experiment. All of you go to this website, students. You will be directed to this page, and here click on the list of experiments. And in list of experiments, our experiment is Lvdt. Click on characterize the Lvdt, and you'll get this page. And here you can go to theory. Students, go through this theory for 5 minutes, then we will do our experiment. Read this theory about Lvdt. Students, next click on the procedure. Read this procedure. And to understand the procedure, you can click on the video. In this video, professor is explaining about the procedure. All of you watch this video. Next, we will do our experiment. Now students, you can click on the simulator. After clicking on the simulator, you will be directed to this page. Here you have to design your own Lvdt, drag your primary coil, drag your armature, drag your secondary coil. Then we have options for the selecting number of turns, voltage, frequency. So I have selected 10, 5, 10. Then you have to press configure. So this is our Lvdt now with the given specifications. This blue color one is input wave, and here we have a graph to represent output voltage. Students, observe here. This is input wave, students. Now I am moving core towards right. Initially, core is at middle position, so displacement is 0, output is 0. We cannot see output on the graphical representation. See, red color one is the output and displacement is 1 mm. If you keep on moving core towards right, red color one is increasing. And if you observe, a dot P will move on the graph. Here we have y-axis. Y-axis readings are units are voltage, and here we have 50 millivolts, and here we have 75 millivolts, and here we have 100 millivolts. Shape of the sine wave of input and output are same if you move towards right or if the output is positive. See, output is positive 75 volts, 75 millivolts. Maximum 10 mm is the highest displacement towards right. Now we will verify towards right, towards left. See, output is decreasing. You can observe the red color wave, it is out of phase with the blue color wave. If blue one is positive voltage, red one is negative voltage. If blue one is negative voltage, red one is positive voltage. Right. See, displacement is minus 10 mm, 1000 negative voltage. P dot P will move on the graph. So this is our experiment today, students. So you have to do experiment with the different combinations. First you take 1000, 5000, and next you can change input voltage. Again you have to do. And next again you can change frequency, that is 3000. So like that, different combinations you have to try this Lvdt experiment. Okay. So I'm giving you 5 minutes time. Randomly I will call your roll numbers. You have to share your screens. CSC 537. CSC 537. Switch on your mic. CSC 537. Students, I am giving you 2 minutes time, otherwise I will remove you from the Zoom session. If you have problem with mic, at least you have to give response through mic, through chat box. CSC 537. CSC 548. CSC 848. CSC 548.
Yes, sir.
Share your screen, Babu.
1 second. So it says disabled participant screen sharing.
Pardon?
So it says disabled screen sharing, sir.
Wait, I'll enable. Yes, can share now. Right.
So this is 1,000, 5 and 5,000.
So near the waveform you have arrows, right?
Sir, near the waveform.
Near the below the waveform, you have arrows.
Yeah. So
Below the
this
wave-
yes, sir. Yes, sir.
Expand the waveform because it is very clumsy. Now, if you press the arrows, you will get right. No, left arrow. You press minus. Yeah. Okay. Increase the size. Plus. Okay. Okay. Next.
So move it to a right a little bit.
Press plus now. Press.
Zoom even more, sir.
Okay, you do one thing, change the frequency from 5,000 to 1,000, then we can easily understand. Right. Move armature, move core.
To the right, sir.
Yes. What are your observations while you are moving core?
Sir, it's in sync. The
Yes.
I
48.
mean, sir, both the curves are the graphs are in sync. Both the graphs are in sync with each other. So the red and blue one.
Both the graphs are
In sync, sir. They're in sync.
correct. Move core towards left.
So now they're out of sync.
Right. Okay, I'm 48. Stop sharing. Yes, CSC 537.
Yes, sir.
Share your screen. Change input voltage as 7. Click on configure.
Yes, sir.
Change it to 7 from 5. Then what you have to do? $37. Hello. 37, is my voice audible? $37. Stop sharing 37. Stop sharing. CSC 559.
Yes, sir.
Share your screen. Okay, I must stop sharing. CSC 553. 53.
Yes, sir.
Share
Yes.
your screen.
Sir, can I show my video?
Pardon?
I logged in my phone, sir.
No problem, you can share video.
Yes, sir.
Disconnect the mobile audio first, otherwise you'll get echo.
Is it visible?
Yes. Okay, Amma. Stop sharing. CSC 551. CSC 551. 51, share your screen. CSC 551. CSC 550.
Yes, sir.
Share your screen.
Sir, can you see my screen?
1 minute, Amma. Yes, right. Change frequency from 1000.
Sir, here I can't see 2000.
Yeah, 3000. What is a LVDT?
Sir, it is a linear variable differential transformer, sir.
What is the use of LVDT?
It is used to find.
Very good. Stop sharing. CSC 953. CSC 953.
Yes, sir.
Share your screen. Yes. Change input voltage 5 to 10. Explain Lvdt experiment. Explain Lvdt experiment.
Sir, if we move the battery to the positive terminal,
Pardon?
if we move the battery to the positive terminal, sir.
Armature, right.
To the positive terminal, it will show the graph. It will show the graph in sync, sir.
Where is the primary coil? Show me primary coil.
This one, sir.
So which is secondary one, secondary two?
This is the
Left side one
secondary
is secondary
sir.
one, right side one is
Yes, sir.
secondary two. Here in the secondary coils.
Okay, sir.
Okay. Next one is secondary two. Okay.
Yes, sir. Yes.
Stop sharing. CSC 952.
Yes, sir.
Share your screen. Explain about LVDT.
Lvdt is the linear variable. It converts displacement in electromechanical to in electrical signal positioning.
In LVDT. Student. What is the use of core in LVDT? $52.
Sir, yes, sir.
What is the core? Armature is nothing but core. Okay.
Yes, sir.
Right. Stop sharing. CSC 951. CSC 951. Students, you have to give response within 2 minutes, otherwise I will remove you from the session. CSC 946.
Yes, sir.
Share your screen.
Sir, just one moment, sir, please.
Okay. Yeah, CSC 938. CSC 938.
Sir, yes, sir.
Share your screen. .38 quick.
Yes, sir. Sir, is it visible, sir?
Yes, yes. Yeah, go to theory page 38. Scroll down. వచ్చేసాను కిందికి వచ్చేసాను.
Sir.
There in this theory somewhere we have eddy currents. Go to that paragraph, eddy currents. Right here. Read out that one, 38.
When alternating current is passed through the coil, a magnetic field is generated in and proximity to a conductive material. The rod's changing magnetic field generates current flow in the material. These are called as eddy currents.
Right. When alternating current is passed through the coil, we are allowing primary coil.
Okay.
A magnetic field is generated where around the primary coil, because of that current flow, we are getting magnetic field. That is the main magnetic field. When a rod is brought in close proximity, rod means our core or main. Okay. The rod's changing magnetic field generates current flow in the material. So, because of this rod, we will get other changes in the magnetic field. Those magnetic fields produce some currents.
Yes, sir.
Right, scroll up. Yeah, here we have residual voltage. Read that 38. We have residual voltage definition.
Output voltage at the null position is ideal.
Exactly at the middle position, that is called null position, because output is 0.
Okay.
If armature or core lies exactly at the middle, output will be 0. That is called null position. Yeah, carry on.
But because of harmonics in the excitation voltage coupling between primary and secondary, a non-zero voltage exists at null position.
Right.
This is
Okay,
called
that's it.
residual voltage.
Right. So students, we are expecting 0 voltage from the Lvdt if core lies at an error. Stray capacitance means if any two conductors lies near, they will act as a capacitor. They will act as a capacitor. If they are not physically capacitor, lies stays in the circuit nearly, they will behave like a capacitor. So that is called stray capacitance, and some more harmonics, some errors in the materials. All these makes difference in the 0 voltage as output, but practical Lvdt will not give that 0 volts as output. We have to control that output to become 0. That is called residual voltage. The voltage which is coming as output when the core voltage. Okay, Matati, right?
Okay. Sir, shall I stop sharing?
Ante. Stop sharing. Okay, 46, CSC 946, try to share your screen.
Yes, sir.
Right. 46, change your number of turns from 1000 to 1500.
Sir.
Lvdt experiment.
So in Lvdt experiment, we are taking a primary coil which is bound to this armature, and we have taken two secondary coils which are in series connected, but in opposite polarity. So when we move this armature, like when it is in 0 voltage, like residual voltage is present, but still that is considered to be negligible. And when we move like towards the right side, then we'll get voltage as voltage produced by secondary coil minus voltage produced by secondary coil 2 side, then it is S2 minus S1 minus S2.
What is the use of core in the Lvdt?
So it is used to change the displacement, so that like in this experiment, when we change the displacement, when we change the position, will also change. So this core or armature is used to change that displacement so as to get the differential voltage.
Differential output.
Sorry, output. Yes.
Okay, right. Stop sharing.
Yes.
CSC 9 CSC 937. CSC 937. CSC 937, you have to give response. Otherwise, I will remove from the session. Yes, CSC 927.
Yes, sir.
Share your screen.
Yes, sir. Yes, sir.
At 27, I am switching off my mic for 1 minute. You be in. You keep on sharing your screen, okay? I will ask questions. Right.
Okay, sir. Yes, sir.
What did you know about the Lvdt device?
Sir, it converts displacement into electrical energy.
Explain construction, explain procedure.
Sir, armature is used to change the displacement, and
We are getting two voices, 27. Who is speaking? Who is another person?
no, sir.
Okay, maybe it is echo.
Outside, sir. Outside, it is a van, sir. They are speaking there.
Okay, my 27. Stop sharing. CSC 930. CSC 916. CSC 916. You have to give response. CSC 911.
Yes, sir.
Share your screen.
Yes, sir.
Go to theory page. Scroll down. Yeah, stop there. Case 1. Read out this case 1.
When no displacement is applied to the core and the core remains in the null position without any movement, then the voltage
Will be 0. Move left, it will move. Move left or right.
either ES1 minus ES2 equals to 0, sir.
What is case 2?
Case 2, when displacement that the core moves in the left direction, then the voltage induced in that left, so I cannot read left right
అది
side.
మూవ్ చేయమ్మా, లెఫ్ట్ కో రైట్ కో మూవ్ చేస్తే ఆ పేజ్ మూవ్ అవుతుంది. Right? How you are moving? Scroll left and right. Okay, go to experiment page. Right. Change frequency from 1000 to 5000 and do the experiment. Move core. Okay. CS11, 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 17, 19.
Yes, sir.
ఎవరమ్మా మీరు? 19 17?
19, sir.
బాబు 19 ఏం చేస్తారు?
Sir,
Yes.
couldn't able to share అనొస్తుంది, sir.
Try now.
Sir, it is saying still same, sir.
Are you able to see my screen? 11 or 19?
Yes, sir.
Explain about primary coil.
Yes, sir.
Explain about primary coil. Where do you have that?
Primary coil, what do you say? Forming the part of electrical circuit.
ప్రైమరీ కాయిల్ ఎక్కడ ఉంది అని అడిగారు. మీ నెంబర్ ఎంత బాబు?
19, sir. Yes,
హలో,
sir.
ఇదేగా మీ నెంబరు? 19.
అవును, సార్.
సో మిమ్మల్ని హైలైట్ చేశాను. సో నెక్స్ట్ వీక్ మిమ్మల్ని అడుగుతాను క్వశ్చన్స్ ఇన్ని స్టార్టింగ్ ఆఫ్ ది ల్యాబ్ సెషన్లో నా ఎక్స్ప్లెనేషన్ అయిపోయిన తర్వాత మిమ్మల్ని అడుగుతాను. వీ హ్యావ్ టు and we have to answer my questions. Otherwise, I will put 0 marks for this lab session and coming lab session. Okay.
Okay.
You have responded, but you are unable to give answers. You have to listen carefully while I am explaining. Okay. Students, not only 19 response, I am noting down. So at the semester end, I will consider all your responses to allot marks. CS 1144.
Yes, sir.
Share your screen.
A linear variable differential transformer has a core and it has two coils, primary and a secondary coil. Core is a movable. It can be, and the position of core is responsible for the varying the differential voltage of the two secondary coils. And if we move the core towards the right, then the coil S, the first coil towards the right, the first coil increases, and if you move towards the left, the second coil increases. The flux of the first and second coil changes if you move the position of the core.
How many coils we have in secondary?
First and second.
Secondary one and secondary. Okay, Amma. Students, if you want to share your screen voluntarily, you can share. I will record. I will note down your screen sharing response. So, your numbers. If you want to share voluntarily, you can use your screens. You can share. 27. 27. Speak out.
Yes, sir.
Your voice is
Yes,
not
sir.
audible.
Sir,
Explain about Lvdt.
LVDT consists of two coils. One is primary and the secondary. The secondary we have another two and a negative, and we have an armature which decides whether we are having a positive voltage or a negative voltage, sir.
It will not. It will helps to get positive voltage output or negative voltage output.
Yes, sir. Based on the moment, either we can
Based
get
on the
positive or negative.
Oh, yes, right. Wait one second. Stop sharing.
Sir, I'm from CS327.
Yes, yes. I noted down.
So can I share my screen?
Yeah. Don't ask me. You can share freely. You're from?
CS 11, sir, 49.
49. 1 minute.
Yes, sir.
What is the use of core in Lvdt?
Sir, we can like it is used to know if the output is positive or negative. And if it is in the null position, the output will be like 0.
It is a movable object. You can move that core depending on the position of the core. Will get different output.
Different output. Yes,
Right. Change number of turns to 1500. Students, tomorrow in this experiment, we have to practice 10 images with 10 different specifications. One image with 1000 turns, 5 volts, and 1000 frequency. Next image will be, you can change either turns or voltage or frequency, like that. So in those 18, you can upload 10 images. Okay. Many of the students are not uploading. I am putting the last date. So if you upload after the last date, I will cut marks. So within that time, you have to upload images. For the previous lab sessions, students, some of the students do it. Right. Okay, ma'am. Very good. 49.